In this video, I'm going to help you set up integrals to evaluate the volume of a solid when you have a region that is rotated over x-axis, y-axis, and some other vertical horizontal lines. Okay, the first thing I want you to remember is that every time you are integrating with respect to x, your limits will be the x limits, right? And how do I know if it's going to be with respect to x? When if it's a horizontal line, so remember equations like these, like y equals a number, that's a horizontal line because y is fixed and x is anything. In this case, you're going to look for x limits. How does x change? And then if it's a vertical line, so it will have something like x equals something, x equals b, right? X is fixed and y is anything. That's a vertical line. And that means that your limits are going to be the y limits. So let's go ahead and immediately put that there. Okay, when I look at the region which is bounded by these green, red, and blue curves, how does my x change? Well, x changes from 0 to 1. Well, y equals 0 is the x-axis, so that's going to be 0, 1. This is actually the y-axis, x equals 0. And how does y changes from 0 to 6 on the region. So this is going to go to 0 to 6. This will be y equals 9. That's a horizontal line. The limits are the same as in part A, because that was also a horizontal line. And here, you could probably guess that would be 0 to 6. The next thing I want you to remember is because everything here is based on the area of a circle, which is pi r squared, do not forget to include pi. What I would do if I were you, I would just immediately put pi everywhere, just in case so I don't forget. And then you're going to be multiplying by something. And whatever that something is, we're going to fill out in a second. But let me just put like placeholders there. Okay. Next, I want to know whether the inside here is going to be a disk or a washer. Now, if it's a disk, the formula would look like this: pi r squared, with r being substituted for whatever's the radius. If it's a washer, then you're going to get pi capital R squared minus pi lower r squared, lowercase r squared. Okay, so which is which? How do I know if it's a disk or a washer? That's the first thing immediately. Okay, so the way you tell is that look at the axis of rotation. So let's say this is y equals 0. This is a horizontal line. Is there a gap or a distance that I have to travel if I am sitting on the axis to the region? The answer is yes, right? So if I'm like right here on the x-axis, I do have to travel. That means it's going to be a washer. If it's a washer, I'm going to have something squared minus something else squared. Okay, so I'm just putting placeholders there. What about x equals 0? Well, if you are on the vertical y-axis, right, there is no distance between you and the region. You are already in the region. So this is just going to be a disk. So this is just going to be 1 radius squared, and that's it. What happens for y equals 9? Well, y equals 9 is going to be a line, horizontal line above the region. There is definitely a gap here. This is going to be a washer. Something squared minus something squared. The last thing is x equals 8. Well, this is a vertical line. It'll be somewhere over here, but there's definitely a pretty big gap between it and the region. So this is going to be something squared minus something squared. Okay. Now, how do we fill out the something? Let's first start with the easier one, which is y equals 0. Well, we have two curves here. We have 6 square root of x and 6. One of them will go into one blank and the other one will go in the other blank. But how do I know which one? Well, the one that's furthest from you, if you are on the x-axis, will go first. If I am on the x-axis, then 6 is further from me, right? The red line is further, so that's going to come first, and then the other one is going to be 6 square root of x, okay? Now, what about over here? Because this is y equals 9, we're going to look at the distance from 9 to one of these functions, 6 square root of x and 6. So it'll be 9 minus that, 9 minus, okay? So I'm just going to be the functions themselves. So just fill this out, 9 minus, 9 minus. But what do I put for the minus? Like, what is it? Well, imagine yourself at y equals 9. So you are here at the horizontal line, y equals 9. Which curve, the blue or red, is further from you? Well, the blue one, which is 6 square root of x, that's why it's going to come first. So this is going to be 6 square root of x, and then this is going to be 6, which, by the way, that's just 3. I could put that, but I could probably also put 9 minus 6, and it'll be okay. All right, so I filled out the x part. Let's fill out the y part. Before we do that, though, we have to convert our okay, so our function, the 6 square root of x, because this is going to be integration with respect to y, I have to solve this for x. Well, how do I do that? Well, I'm going to divide both sides by 6, so I get y divided by 6 equals square root of x. And then I'm going to square both sides to get rid of the square root. So this will be y squared divided by 36. So the blue curve now is not 6 square root of x. It's now y squared over 36. But everything else applies. Okay, so over here, I know there is only one radius. This is x equals 0, distance from me to the blue line, which we just found is just going to be y squared divided by 36. We don't have to subtract anything because that's the axis. What happens here? Well, this is a line x equals 8, so it's going to be 8 minus 8 minus. Well, minus what? Well, okay, so at x equals 8, you imagine you are over here somewhere. What is the furthest from you? So you are here somewhere. The further from you would be the green line segment, right? Which is really just, what is that? That's x equals 0. So that's x equals 0. That's just going to be 0 right here. And then the closest from you, if you are over here, is the blue curve, which is y squared over 36. So that's going to go in here. Okay? Let me check my work. I think that's it. Okay.